my name's Chris Newland. I've been programming in Java since about 1999, more or less from the beginning. Most of my career I've spent in the financial services industry, dealing with market data, so lots of messages happening very quickly all the time. It's been a very interesting domain to work in, and I've been predominantly working in Java for that. In terms of JavaFX, I became familiar with that when I started putting some user interfaces on some trading software. And I found it a nice, easy technology to use. I used Swing before. I was fairly familiar with the way the sort of various layout components work. But I think JavaFX being new and it didn't remind me of AWT, so I think it was an exciting new technology. One of the ways I got into JavaFX is I've always been interested in, I suppose like a lot of people, my interest in computers starting out with video games and also the demo scene. So back in the early 90s with the Atari ST and the Amiga, I used to sort of sit in the dark watching demo scene productions, watching people showing off their coding and their graphical skills. I used to work in London. Now I work fully remote, but I used to code on the train. So I had a little 10-inch netbook, and I used to use JavaFX and to make like little demo scene effects. And that ended up me developing a little sort of demo scene framework, which is called DemoFX. It's built in JavaFX, and one of the things it allows you to do is it provides all the scaffolding. So you just write literally one method that's the render loop for a particular effect, and you can layer those effects together to build up more complex effects or full demos. And there's a timeline sequence there, and so it's just a bit of fun, really.
Fun to show what can be done with JavaFX. You also created all these as open source projects, so that's everyone right. Can just play with them. Let's just jump into a demo and show what you've created.
Sure. Okay. Yeah. So this is a single effect. I hope you can see that. This is basically a star field. This is using the JavaFX canvas component. So with JavaFX, got a node way of doing things where you can have rectangles and lines and shapes and things, but you've also got a canvas, which is more of a canvas is an abstraction over a pixel buffer, so you can do pixel effects if you want to with JavaFX. So this is an example of one effect, and if I stop that, I can then layer a second effect over the top. There's some sprite text rotating over as a second layer, and then I'll bring in another effect. This is some pseudo 3D, a little 3D object rendered as a bunch of sprites, which is scaled for distance. Some of these effects are borrowed from the DemoFX 3 production. You can find all of my DemoFX videos on YouTube. And just a fourth effect layered over the top. Again, this is all done with sprites on a canvas. One of the things I've heard, Almus Bain did a video recently where he was demonstrating some shader programming.
Yeah, indeed.
And apparently that's coming out in JavaFX 25, and that'll be really exciting. Basically, shaders are tiny little programs that operate on pixels and can be used to do things like blurs and neons and all kinds of different rendering effects. And these tiny little programs are compiled into the language of the GPU, so they can be massively parallelized on the GPU. So you're not forcing your CPU to do all these per pixel effects. So it'd be really interesting to see how that works with JavaFX. So that can make it a lot more powerful.
So what we're looking at now are all examples integrated in DemoFX, right?
That's right. Yeah, there's a ton of different effects that you can show. And actually, I'll just very quickly switch to a couple of the productions I've done. I'll just show you. There was one I did called Fractal Rings, which is basically just using recursive programming to fill circles all the way down, and just another JavaFX, and I've made some YouTube videos of these. The frame rate, unfortunately, is getting a little bit impacted by the recording. But it's something I enjoy doing. It's a little bit of fun, and sort of tests what's possible in JavaFX. as well as the fun stuff, I use JavaFX in my day job. One of the things that I've created, probably the thing that most people might have heard of me for, is JITWatch. Now, JITWatch is a program which allows you to understand the performance of your Java program when it executed. So Java is an interpreted language. You write your Java code, you compile that with Java C into bytecode, and that bytecode is portable. It can run on any architecture. So x86, ARM, pretty much every architecture, RISC-V now. The JVM will start interpreting that bytecode, but it interprets it and executes it as a stack machine. So to add two numbers together, you push one number on the stack, you push another number on the stack, you call the add operation, and the operands pop off, and the result is left on the stack, which is not which doesn't have a good mesh with the actual architecture of a traditional traditional CPU register-based machine. So since I think Java 1.3, we've had the hotspot engine in the Java virtual machine, which instruments the code as it runs. So as the bytecode is being instrumented, it profiles the bytecode and finds what's being called a lot, so i.e. the hotspots in the code, and it will take the bytecode, form an abstract representation of that, and then compile that to the native code for the target CPU. So ARM, x86, RISC-V, and the JVM logs those decisions in a humongous XML file, which is almost impossible to read by eye for anything but the most trivial programs. You can also use a disassembly plugin like HSDis to get it to dump the actual raw assembly too. So I made a visualizer for all of that in JavaFX. So that's what JITWatch does, and this is written using a JavaFX user interface. So various sort of dialogues and panes and panels and things. So you take your Java program, you execute your Java program. The JVM instruments it, and then it will show you what that program looked like at runtime. So there's the source code, there's the corresponding bytecode for the selected method, there is the disassembled assembly code, and all of this is in JavaFX, and you can hyperlink things. So you can say, okay, where does this call here appear in the native code? Where does it appear in the bytecode? You can also do things like look at okay, let's see what was the free space in my code cache as my program executed, as more methods were compiled into native code and the code cache filled up. Things like at what time in the program did various methods get compiled into native code, and you can look at things like actually the code cache visualization needs fixing. I've not updated that since we had segmented code cache. You can look at what were the size of the native methods produced, what were the bytecode sizes, when during the execution of the program did things get compiled, and what were the queues, how many tasks were waiting, how many methods were waiting to be compiled by the C1 compilation unit and by the C2 compilation unit. So I recently had a conversation with someone from the JetBrains team, and they wanted to use JITWatch in order to understand the startup time for the JetBrains various IDE products. Unfortunately, one of the problems they encountered was that JetBrains Java IDEs are developed basically on Swing technology, so it was difficult for him to integrate JITWatch into the JetBrains ecosystem. So he produced a new project called JITWatch 4i, and there's a blog post that was published yesterday about that, and he's really gone into the details of understanding startup times.
If you really dive into how Java operates, the Java virtual machine when it runs, that's actually a very complicated process that most developers are not aware of, that the Java code that you write gets compiled to class files with Java C. That's what you start, but what is actually being executed changes the whole time. So it takes your bytecode, the class files, and then starts compiling it to native code, like you explained, and then this whole process of going to the most optimal native code for your system takes some time, and you have so that you can now visualize this with a tool like this. for people who want to really dive into how is my code executed, this is really amazing. I was lucky enough to review this book. So this really explains how the Java code that you write, how it's really executed on the machine. And it tells you that this story about going from Java to class and how these class files look like. But you go a level deeper. You really go to the assembler code that's generated.
Most Java developers don't even need to worry about this because the hotspot JVM is so good at doing this. Most of the time, you don't need to worry. It will do all the optimization for you, and you don't have to write your code in any special way. If you write your code in a sensible development style, so keep your methods short, have loose coupling and good sort of modularity for reuse, then that won't get in the way of the JVM optimizing your code. I mean, yes, there are some corner cases, and tools like JITWatch are there to help you with those corner cases. I.e., you've written your code in a nice idiomatic manner, but you're not getting the performance you're expecting. Then, yeah, sure, go into JITWatch and check that the methods have been inlined into their call sites. If that's important to you, if you've got a method which you know is a really hot method, it's called inside a loop all the time, but for some reason it's not benefiting from escape analysis, which reduces the amount of garbage produced. So it's not benefiting from locks being removed, being elided. Again, because this method wasn't inlined correctly. This is the kind of tool that can get really under the hood and show you. So you can hover over things and say, yes, this was inlined, and yes, this was inlined, and this was inlined, and these allocations were avoided through an optimization called escape analysis. It makes you a better developer, having an idea of what happens when your program executes. But these days there are alternatives. There's ahead of time compilation. We've got GraalVM. And we've also got the Gluon technology, which is produced by Gluon, which is closely associated with JavaFX user interface layer. One of the things I've done recently is I've started building some apps. My youngest son is 7. I've started building some apps that he can use on his iPad. Things like sliding coins around on the screen to make different amounts. I've done that using JavaFX or the Gluon version of JavaFX. And once you've got it set up, it's very simple to take that code. You can deploy it on your desktop on any platform, so Mac, Linux, Windows, or you can compile it for iOS, or you can compile it for Android, and it's the exact same code. Nothing changes, and that's using the substrate VM and the GluonFX technology layer, which I think is an amazing piece of technology to allow you to write cross-platform plus mobile platforms, all using Java and the JavaFX components you're familiar with.
Yeah, and I know that Gluon is also working, Johan Vos from Gluon, on Java for mobile, so that even Java itself is better suited for mobile development. So JavaFX is then just a layer on top of it. But indeed, yeah, there are only a few JavaFX applications out there on the app stores, but indeed you can create any kind of application for smartphones, being Android, being iOS.
It really does allow you to take any program you can create for the desktop platforms, anything you've already written in JavaFX, and plus it gives you components that are sort of specific to mobile, things like the bottom nav bar and the hamburger menu and things like that. There are components in the GluonFX environment and the ecosystem that aren't in the sort of the desktop vanilla OpenJFX.
It's nice that you use your knowledge about JavaFX to then again create something for your kids. I have the same thing going on here, but
I saw your Java Champions video about MelodyFX. I thought that was brilliant. I've got a bucket full of abandoned JavaFX projects that I need to complete. One of them is a mod tracker, which basically plays mod files in JavaFX. So I've got the code to like load the samples and sequence the samples and play the mod files. And I started working on a little drum machine simulator in JavaFX as well. But those are in my bucket of abandoned projects. Since I work remote, I don't have any train time anymore, so it's a bit harder to find the time to work on open source.
Yeah, that's a bit the problem with if you're a very enthusiastic developer, that you start too much projects and you have a graveyard of unfinished, abandoned projects.
Yeah.
Anything more you want to show or talk about?
There's a few more open source projects on my GitHub, which is Chris Who Codes. I did there's a famous renderer called the ray tracer called the business card ray tracer, which basically is so small. It's written in C and it's so small it fits on a business card, and it's the tersest code you'll ever see. And I spent a few evenings decoding that and porting that into Java and JavaFX, and that's one of the projects on my GitHub where you can basically ray trace a scene in JavaFX, and I'd like to go a bit further with that one. That's something I'd like to explore more. I've always toyed with the idea of actually making a demo scene production and taking it to one of the demos. I know revision party's happening in April this year, and there's Nova party in the UK, and maybe with GraalVM compiling it to a native executable, it could actually be a contender. So that'd be quite fun to do.
Okay, so a lot that we can follow on your GitHub or on your social accounts to see what's happening in the future. Where do you see JavaFX going? So there's a lot of evolutions going on in Java itself. So we have the 6-month release cycle. JavaFX is following that, so also the 6-month release cycle. Do you see any upcoming changes, like you already mentioned the shaders? Is there more?
There are plenty of people working either in open source or contributing to the OpenJFX project, putting new features in. I see. I'm on the mailing lists. I see people suggesting sort of new lighting models for the 3D. There's the shader thing. I saw recently that Johan is producing a build system for building the JDK and JavaFX together. And I think as we've got Project Leyden coming up in the JDK, which is more AOT focus for Java. I think the ability to produce ahead of time builds that incorporate the JavaFX platform will make developing desktop applications in Java easier in the future. I mean, JavaFX was always part of the core platform until JDK 10, and then after that they removed it, modularized it because not everybody would need the JavaFX platform. But if we've now got ways of producing ahead of time builds which incorporate the JavaFX UE technology back in, and that becomes a very simple method for developers to add user interfaces to their Java applications, just like it's quite easy in Python and other languages to import a user interface package. If it becomes as simple as that to produce ahead of time builds, including the JavaFX platform, then I see a positive future for JavaFX technologies.